2 days introducing some new functions. They're basic equations, so the parent functions. This will be part of what I'm going to ask you to do is I'm going to give you an equation, and we're going to do two things with that equation. Here, at least to start, we're going to name the equation. So every time we see an equation, we should be able to decide, is it linear, absolute value, quadratic, square root, cubic, or cube root? Then we'll kind of draw just like a general shape. So actually having the sheet that we built last time might be helpful for this if we don't remember the shapes, but we're going to also graph them using the calculator, so we'll get the shape from that. But naming is going to be really important. And so what's going to happen is we're going to take or see an equation that has transformations built into it. So the value of A, H, and K will show up, and we're going to identify what is going on with the graphs with the equation we have in front of us compared to its parent function. So just a reminder, okay, and this is what we had done on Friday, for those of you that weren't here, is we took just a general equation and talked about all the transformations that show up in an equation. Okay, well, we're going to summarize that again right now. So even if you weren't here Friday, if you don't have this, we're basically going through the whole thing. So I want to point out one thing before we talk about what H, K, and A all do, and that's that they're all in the same location. Okay, so if you look at all these equations, the K value is always in these parentheses or inside the function operation. That's what you'll hear me say most often, is it's inside the function operation. The K value happens after the function operation. Okay, so either showing up after the parentheses, okay, or after the squaring, after the square root. Okay, but again, the language you'll hear me say is after that function operation. And then the A value is in front of the actual function or right after the equal sign. Okay, so they're all in the same place regardless of the equations we're working with. So in general, this H value, and what I think about here is it's attached, not attached, but it's added or subtracted next to the X. And the reason I start with that is that helps me figure out that, oh, the H value is our horizontal shift. So that's going to take our parent function and it's going to move it either left or right. Remember that the sign that we see in the equation is opposite from the shift that we're going to do. Okay, so we need to make a note that this is, the sign is opposite. And you'll see what I mean when we actually start identifying some of the transformations here shortly. All right, and then I've already mentioned this, but let's write it down that the H value is located inside the function operation. Another way to think about it is that it's added, so plus or minus from the X. Okay, so it's added or subtracted from the X. But again, I like that inside the function operation best. So inside the parentheses, inside absolute values, inside the squaring, inside the square root, inside the cubing, inside the cube root. Right, then the K value. This happens after the function operation, so it is located after the function operation. It's not like it's directly added or subtracted from the Y, right? Because it's all the way at the end of the equation. So that might be another note that we can make here, is that it happens after or at the end of the equation. But I think after the function operation is probably the best way to kind of describe where it's located. And the K value, that's our vertical shift. So that moves our graph up and down. And that sign stays the same. So if it's positive, we would expect it to move in the positive direction when thinking vertically. So positive is up. Negative, when we're talking vertically, that's moving down. And again, this says vertical shift. The sign stays the same. and then here after the function operation. All right, then the a value, I think when we had done this lesson the first time, some of you picked up on that it kind of changes the slope. I'm not going to use the word slope. Slope really only applies to linear equations where it's constant. Most other equations, the slope is just changing. So we're going to describe the a value as being a vertical shift or compression. Vertical stretch, not shift. So vertical stretch or a vertical compression. The vertical part is important because there are such things as horizontal stretches and compressions. We won't cover that in this class. That's something that you'll do more next year in pre-calc. So vertical stretch, vertical compression. And it's a vertical stretch when that a value is greater than 1. And really we should be saying the absolute value of a. Okay, because the sign of that a value is something completely different. So if we see an a value that's anything other than 1, it's either being stretched or it's being compressed. And it's compressed when the absolute value of a is between 0 and 1. Okay, so basically a fancy way of saying a decimal that's smaller than 1. Or a fraction that's smaller than 1. All right, the a value is located before the function operation. You could also say that it's right after the equal sign. Okay, so before the function operation or right after the equal sign. I don't know if the sign of the a value is what we should think about here, more as what happens if the a value is negative. So if a is negative, the graph is reflected. And it's reflected across the x-axis. Oops. And all of those transformations, again, are a summary from what we had covered on Friday. We even finished a little bit of that. And actually, that was all Friday. All right, and once you have this down, go and flip the page over. And we'll start putting all this to use. This is where we'll start using some graphing calculators and actually seeing these transformations. So what's nice, like in the past when I've taught this lesson, I haven't had this many graphing calculators. We haven't incorporated that. It's going to be really nice because we can see these transformations here in the graphing calculator. Okay, everyone good here? Okay. All right, so we're going to be given a function. We're going to, one, identify the parent function. We're going to name the type of function. And then we're going to identify all the transformations. The last thing we're going to do is draw a sketch of the graph. That's where we can kind of see the comparisons between the parent function and the new one that's been transformed. So we're really going to do a little bit more than what's being asked right here. So when we're describing a graph compared to its parent function, we're identifying the vertical shift, the horizontal shift, whether it's stretched or compressed, then if there's any reflection. And all of that we should see in the equation. So, number one here, I am recognizing that the function operation is to take the square root. Thus, this is a square root function. And the parent function, we'll abbreviate it PF, is just g of x equals the square root of x. If you want to use y, that's fine as well. But I want us getting more and more familiar with this function notation. Okay, so that says square root function, that the parent function is the square root of x. Now, the reason I want us writing down the parent function, because anything else that's different in this equation is a transformation. So this 3 here is doing something to the parent graph, and this -4 is doing something to the parent graph. Okay, so we need to identify what is each of those doing. Well, the value inside that function operation, so inside the square root, is our horizontal shift, right? It's being added on to the x. That sign is opposite, so usually if we see a +3 and think about how can x move in a positive direction, we would think that moves right, but the sign is actually opposite. So this +3 shifts the graph. Left 3. And then that -4 happens after the function operation. So that affects our y coordinates, and that's going to shift everything down 4. That sign does not change. And we're going to take a look at these transformations with the calculator right now. So f of x is taking the parent function g of x and shifting every point left 3 and every point down 4. Lucy, did you have a question? Yeah. Totally. Yes. Yep. Yeah, and that's why I mix all these equations in there, because we see that all these transformations, it's the exact same. So what we're doing is we're graphing 8 different types of functions in here, kind of going by this same set of rules to be able to do this. Okay, and that's what our next lesson is going to be. Is we're going to actually graph all these things without the calculator. Okay, but for today, let's take a look at these transformations and compare them. Okay, so in the calculator, again, we're just going to unlock your iPhone first. Okay. I don't know why Siri thought I was talking to her. Interesting. Okay, anyways, we're not going to do anything with the tables today. We're strictly just going to look at the graphs. So, again, do your best to follow along with the buttons I'm pressing. If you get behind, don't ask a neighbor, because that will get them behind as well. I'll explain everything a couple times here. So we're going to put both the parent function and the transformed function, or the child function, all in the same on the same graph. So we're going to press y equals. I want us to clear what is ever in there. And then y1, let's put the parent function. So we're going to put the square root. And to get the square root, you need to press seconds. And then you need to press the x squared button. So if you look right above x squared, you'll see the square root. So second square root. And then the variable button is right next to alpha. Okay, there's 4 letters on there, x, t, and then that's theta, and then an n. So we're just going to put the square root of x. It depends on the mode. You will never need, in this class, you'll never need the other 3 variables. Okay, these calculators can be in different modes, kind of operating under different systems. That's something that you do in, like, not even next year. That's a couple classes away from most of you. Okay. All right, then in y2, let's put in the new equation. So once again, we need the square root. So we're going to go second square root, and then x plus 3. Now this is where everybody's going to have to do something a little bit different here. If your calculator is a little bit older and it displayed an open parenthesis, you need to close the parenthesis. Okay, so if you're using, can I see this for a second? For some of you, if you're using this equation or this calculator, notice how it shows the square root symbol, but then opens a parenthesis. You need to close that parenthesis before you do anything else. Okay, I know that's hard to see. Oh, there we go. Now you can see a little bit clearer. Okay, so there's about half of you that need to close the parenthesis. If yours actually extends that square root bar, all you need to do is hit the right arrow key so you move past that, and then you can go -4. But you want to make sure the -4 is not underneath the square root. And then to get to the graph, we're going to press zoom, and then 6. That brings up the standard window. And the first graph we're seeing here, and this is what's nice about the newer calculators, is the colors. Okay, the blue graph is the parent function. Then the red one is the transformed function. Okay, and yeah, the colors really don't make a difference here. So here's what I want us to add on to all these questions is let's just sketch what the new graph looks like. And I'm gonna come around and troubleshoot anybody that the calculator's not working. I'll come around and help you with that in just a second. Okay, so we're gonna draw a quick sketch of the transformed function. So that's left 3, down 4, and then just kind of show what it looks like there. Okay, so that we're seeing the shape, but then also all those shifts as well. We're not going to get specific points yet. That's something we'll extend into tomorrow. Okay, so let's do this. Number 2, getting the cube root function is a little tricky, so why don't you all try number 3. Identify the transformation, see if you can graph the parent function and the transformed function, and I'll just kind of circle around, and for those of you that had trouble graphing this, we can come take a look and make sure you're able to do that. If you didn't use a calculator the first time, trade with somebody. Again, I need us to be... So number 3, let's first identify the transformations, and this is something we should be able to do without a calculator. And again, I always want to start with what is the name of the function and what is the parent function. So the name here, okay, for number 3, this is a cubic function. I know that it's cubic because of the exponent of 3. I'm doing 3. Then the parent function is x cubed. Okay, the most basic equation without anything else. Everything else in that equation is a transformation. So compared to what we did before, I think a lot of us could figure out that this 6 is our horizontal shift, and that's going to shift everything right. So shift right 6. It's the opposite sign, or the sign is opposite from what we think it should do. Okay, so negative, I would think that would shift it left, but it's the opposite, so it's moving everything right. Then the 7, that shifts everything up 7. Now, the last thing is this negative. That's still a transformation. And that's why I want to starting with what is the parent function, because again, anything else that's different is a transformation here. So this negative is a reflection, and it's a reflection across the x-axis. So that's the main things that I for sure want us to be able to do with all these equations. And so now, let's go back over the graphs. So everyone pick up those calculators, and if you didn't press the buttons along the first time, let's do that now. And let's take a look at both of these equations here. All right, so in the calculator, we're going to go back to the y equals window. y1, we're going to change it to its new parent function, which is the x cubed. Okay, so I'm going to go x to the power of 3. And I did that a little fast. That exponent button is right here above the division sign. Okay, it's like this upwards arrow. It's referred to as the caret button. So some of you, it'll actually show the caret. So you'll see like x and then the caret and then the 3. For me, it allows me to change that exponent there. Then for my new function, I need to start with the negative. And you need to be careful here because you can't press the subtraction button. The subtraction button is going to give you an error. Instead, you need to press the button below 3, which is the negative. Then you need to open a parenthesis. The open parenthesis is right above 8. and then it's x minus 6, and then close the parenthesis, and then to the exponent or power of 3, and then plus 7. When we graph this, and again, I'm going to zoom 6. This cubic function, it grows really quickly, so it may be a little hard to see here. Here with that blue, that's my parent function, and then there's the red, where I'm seeing that it's moved to the right. It's also up 7. I'm kind of focusing on this like kind of hitch in this graph here to kind of see that transformation. And then the reflection, that's why this left side is going up and the right side is going down. Okay, so that's where we're seeing the reflection there. So what I want us to do is on our sketch is just sketch the new function, which is right 1, 2, 3, 4, 5, 6. It's up 1, 2, 3, 4, 5, 6, 7. And then just a quick sketch for what the shape looks like. It does not need to be perfect. Yeah, and so the parent function is always going to have a starting point at 0, 0, right? So that's, for those of you that don't have like the different colors, that's how you'll be able to tell. Okay, if it hasn't been moved yet, that's the parent function or your original. Yeah, yep, the one that's been transformed, the one that's been moved. Okay, let's go back and do number 2. The graphing calculator portion is a little bit different here, especially with that negative 1/3. But let's start this the same way. So identifying the function. This is your cube root function. The parent function for it is the cube root of x. And so everything else is a transformation. So everything else is going to do something new to these equations. So the negative 1/3. That actually is 2 transformations in one. The negative makes it a reflection. And it's a reflection across the x-axis. And then with the 1/3 being between 0 and 1, so since a, the absolute value of a, is between 0 and 1, that's going to take the graph and it's going to compress it. So it's a vertical compression. And I'll show you how we can see that when we graph this here in a second. All right, then the other transformations, we have this x minus 2, which takes everything to the right 2. And then this plus 1, shifting everything up 1. Okay, so let's do the exact same thing. Again, if you have not used the calculator, make sure you rotate so somebody else is getting some practice with this. And back to y equals. The cube root option, you have to go into the math window. There is not a cube root button that just exists on the calculator at the moment. It's hiding. So you need to press math. And then you need to scroll down. For me, it's option 4. I believe it should be the same for just about all of you. So option 4. I'm going to put just an x there, so I'm taking the cube root of x. Then in my y2, let's clear what's in there. And this is what I was seeing from a lot of you. The fraction needs to go into parentheses. Okay, otherwise the calculator gets confused with the order of operations. And so anytime you see a fraction and you're using the calculator, put that thing in parentheses. That will save everything that you're doing. Okay, just make it a habit that 100% of the time that you see fractions, put it in parentheses. So open parentheses. I'm going to make or include the negative there by just making the numerator negative. So negative 1 divided by 3. And then I close the parenthesis. So I have the negative 1/3. Then, cube root function, I have to press math. I need to scroll down until I find that cube root. And then we wanted cube root x minus 2. Again, for a lot of you, you might need to close the parenthesis there. For me, I need to hit the right arrow key so I get out of that square root option. And then +1. So you want to make sure that the +1 happens after the function operation there. Then we can just press graph. The window has not changed. And there's our parent function. And then here's our transformed function. So I'm definitely seeing the shifting right. I'm seeing the up. It's moved up a little bit. The compression's hard to see here, right? Because of this graph doesn't grow very quickly. But there is, like, if we were to zoom in. So zoom in, and I'm going to try to zoom in on both of these, like right there. You should see this part where, like, this hitch, it's a little steeper in the parent function than what we should see it in the transformed function. Okay, so that transformed function, we should see that it's been squished down just a little bit, right? And it's not as steep there for quite as long. So that's where we're kind of seeing that compression. So again, for the drawing, all I want to see is that we're going right 2, up 1, and then just drawing some ideas to what this shape looks like. Okay, so let's do this. The graphing is extra. Okay, if you're like Mr. Younger and I'm having trouble with the graphing part, that's fine. Okay, that's not something that you need to do today. In fact, tomorrow we're going to graph the functions without a calculator. Okay, we won't even use them. Okay, we might use it to check. But here's kind of what I want the main takeaway to be for today and what your homework is going to have you doing. Is you see the equation. We need to first name the function. So this is an absolute value. The parent function is just the absolute value of x. So then everything else does something new to the equation. So this -2 shifts everything right 2. This +4 shifts everything up 4. And then this 3, because it's greater than 1, that's going to be a vertical stretch. And again, the calculator part is just extra. If you've got the calculator part down, keep doing it, because it'll make everything else a little bit easier. All right, then number 5. This is a quadratic function. The parent function is x squared. And so then everything else does something to this equation. Let's start with the -1/2. So the negative makes this a reflection. The 1/2, because that's between 0 and 1, that's going to vertically compress our graph. So it's a vertical compression. And then the only other thing that's going on here is this +5, which shifts everything left 5. So everyone needs to do that. Okay, identify, list the parent function, name the transformations. The graph part is extra. We will continue to get practice with that. And I will